Hi students, good morning. Hope you all are keeping fine and staying safe at home. Due to lockdown, we could not start our regular classes as it was scheduled earlier. So we are starting online classes. Myself, Beena, going to teach you physics. You may keep the textbook and notebook with you and note down the important points while watching this video. Let us start the first chapter. In first chapter, we will discuss 4 main topics. First one, force and its units. Second topic, moment of force and equilibrium. Third topic, uniform circular motion. And fourth topic, center of gravity. Let us start the first topic, force and its units. You have studied in lower classes about force. It is either a push or pull exerted by a body on another body. And force have some important effects. We will go through, we will just revise the important effects of force. First one, force can start motion. When we kick a ball at rest, it starts moving. So force can start motion. Force can stop motion. When we apply the brakes of a vehicle, it stops due to the frictional force. So force can stop motion. Force can increase the speed of motion. Force can decrease the speed of motion. Force can change the direction of motion. For example, when a batsman kicks the ball, the direction of the ball changes. Then force can change the dimension of a body. Dimension means shape of the body. When you squeeze a lemon, its shape changes. So these are some important effects of force. By including all these points, we can make a definition for force. Force is an external agent which changes the state of rest or motion in a straight line or changes the dimension of the body. Now, about different types of force. Forces are classified into 2, contact forces and non-contact forces. Forces which act through physical contact are called as contact forces. Means in that case, both the bodies, the body which exerts force and the body on which force is exerted must have some physical contact, either directly or indirectly. That type of forces are called contact forces. We will go through some examples of contact forces. First one, frictional force. You know what is frictional force? For example, imagine a wooden box kept on a table surface and you are trying to push it in this direction. Means you are applying some force in this direction and the body starts moving. While the body moves forward, this table surface exerts an opposing force in the opposite direction of this applied force. This force exerted by the table surface on the wooden block is known as frictional force. This frictional force acts only when the wooden block is in contact with the table surface. So it is known as it is called as a contact force. Then another example, normal reaction force. Look at the diagram. A wooden block is kept on a table surface. You know the weight of this wooden block acts downward. That is the gravitational force exerted by Earth on it. Then the table surface exerts an opposing force against gravitational force, which is called as normal reaction force. Weight acts downward. Weight is the force exerted by Earth on the body. It acts in downward direction. And the table surface exerts an upward force on the body, which is called as normal reaction force. And it is also a contact force because this normal reaction force is exerted by the table surface only when the wooden block is in contact with the table surface. Then third example, tension in a string. Tension in a string is a contact force. Suppose a wooden block is suspended with a thread. In this case, weight of this block acts downward. At the same time, some opposing force or tension force acts on the string in the upward direction. And tension on this string is in opposite direction of weight. And this tension force acts only when the string is in touch with or contact with the body. So it is also a contact force. Then next one, force on a stretched spring. This is another example for contact force. Look at the diagram. Imagine a spring having some load attached with it. In this case also weight acts downward. At the same time, on this spring, some restoring force acts in the opposite direction. And this restoring force acts on the spring only when the spring is in touch with the load. So it is also this restoring force on the spring is also a contact force. Another example, force during collision. Look at the diagram. Two bodies, A and B, moving towards each other. After some time they collide each other. While colliding, the body A exerts some force on B and an equal force is exerted by B on the body A. These forces are equal. Due to these forces, after collision, they get separated. They move in the opposite direction. And this force acts when these two bodies are coming in contact. So it is also a force of contact. So these are some examples for contact forces. In all these examples, the force acts when the two bodies are in contact. The body which exerts force and the body on which force is applied. Now, about non-contact forces. There are some forces which do not involve any physical contact to act. That means without physical contact, some forces can act. Let us see some examples. Such forces we call as non-contact forces. First one, gravitational force. About gravitational force, we have studied in 9th class. It is the force of attraction happening between two bodies. Consider two bodies of different mass, small letter m and capital letter M, kept at a distance d. I mean distance between the centers of the two bodies is d. Then there will be some force of attraction happening between these two bodies, that is called gravitational force. Let me name the bodies as A and B. The body A attracts body B towards it. With same or equal force, this body B attracts A towards it. They attract each other. That force is known as gravitational force. It exists between any two bodies, whether they are of less mass or heavy mass. This force of attraction is there between any two bodies, which is known as gravitational force. Then, the gravitational force between these two bodies is directly proportional to product of their masses, small letter m into capital letter M. Second fact, this force of gravitation is inversely proportional to square of distance between them. Distance between the two bodies is d. So F is proportional to 1 by d square. This law is known as inverse square law. F is inversely proportional to square of distance between them. So these are the two factors that determine the force of attraction between the two bodies, which we call as gravitational force. Then this gravitational force, regarding gravitational force, you have to remember an important point. It is only attractive in nature, only attractive. Then when the distance between the two bodies increases, the force decreases, force of attraction decreases. Let us see what will happen if the distance between the two bodies become doubled. Same bodies, means this is of small letter mass small letter m, this is of mass capital letter M, distance and remain doubled. Now, how to calculate the force of gravitation between these two bodies in the second case? Again, first point, F is proportional to product of the masses. Mass is same, not changed, same mass. And distance, next point, F is proportional to 1 by 2d all square. That means 1 by 4 d square. So look at the change came in the force. Here, the force was inversely proportional to 1 by d square. In this case, when distance became doubled, the force became 1/4. That is the meaning of inverse square law. Suppose the distance becomes 3d. Between the two bodies, the distance becomes thrice 3d. Then the force will reduce to 1 by 3 square. It reduces to 1/9. This is the meaning of inverse square law. Then another example for non-contact force is magnetic force. It is another non-contact force. It is very familiar topic for you. Between two magnetic poles, there can be either attraction or repulsion. If the two poles are opposite poles, they will attract. Even if we keep them at a distance, there will be an attraction. Between two similar poles, there will be repulsion. So, gravitational force as well as magnetic force both can act without any physical contact. So, both are non-contact forces, but gravitational force is only attractive in nature, but magnetic force can be both, either attractive or repulsive. One more non-contact force is here, electrostatic force. Another non-contact force. It is the force between two charges. It also can be of two types, either attractive or repulsive. They also act at certain distance. For example, if you keep two positive charges nearby, they get repelled. If one positive charge is brought near a negative charge, they get attracted. So between the two charges, when they are kept at certain distance, there is some force of either attraction or repulsion. So all these three forces can act without physical contact, so they are called as non-contact force. And there are some general characteristics of these non-contact forces. Non-contact forces, for gravitational force it is only attractive, but these two are either attractive or repulsive. And all these non-contact forces obey inverse square law. And these forces can be either of low range or high range. That depends on the body. For example, gravitational force between two light bodies, it is of very small range or very low, less force. But if the two bodies are heavy, like the two planets, then it is very high. So its range varies from very low to very high. Now we will discuss Newton's laws of motion. Just we will revise it briefly. There are three laws. First law states that a body will continue in its same state, either state of rest or motion, unless acted upon by some external forces. That means a body at rest will continue in the same state till some force acts on it. Similarly, a moving body will continue the motion in the same straight line if no force acts on it. Okay, then so this law, Newton's first law, tells that a body can't change its state by itself. A moving body can't stop by itself. A body at rest can't move by itself. The inability of a body to change its state by itself, that is known as inertia. So Newton's first law is also known as law of inertia. And this law tells the quality of force, what force can do. Quality of force is denoted in Newton's first law. Then in second law, it states that the rate of change of momentum is directly proportional to the force applied on a body. These are just a revision of previous classes. Rate of change of momentum is directly proportional to the force applied. Momentum is the product of mass and velocity. This momentum is a term connected with moving bodies. You can find out momentum by multiplying mass with the velocity. Then what is the meaning of change in momentum? The symbol for momentum is P. Change in momentum symbol is delta P. The formula is delta M into V. Change in mass into change in velocity. Usually for moving bodies, the mass remains constant. So you can write it as M into delta V. Formula for change in momentum. Newton's second law states that the force applied is directly proportional to rate of change of momentum. That means F is proportional to delta P by delta T. Delta P means change in momentum. Delta T means time interval. Okay. Then in the place of delta P, you can write M into delta V upon delta T. This delta V by delta T is the rate of change of velocity, which is known as acceleration. So you can write it as proportion M into A. Delta V by delta T, that is the rate of change of velocity, which is equal to acceleration. Then finally we will come to a formula. F is proportional to M into A. So you can change it into an equation. F is equal to a constant K into M into A. Value of K is the constant of proportionality. Its value is 1. So the final formula, this is the mathematical form of Newton's second law. Force is equal to mass into acceleration. So second law tells how to measure the force. It is the product of mass and acceleration. So Newton's second law is also known. It is it tells the quantity. It defines the quantity of force. First law tells the quality of force. Second law tells the quantity of force. Now third law. It is very familiar to you. For every action, there is an equal and opposite reaction. That is Newton's third law. And remember, action force and reaction force are acting on two different bodies, so they never cancel each other. These are Newton's three laws of motion. Now again a revision of class 9th topic, equations of motion. You have studied three equations. V is equal to U plus AT, S is equal to UT plus AT, half AT square, V square is equal to U square plus 2AS. All these equations you have studied in 9th class. U stands for initial velocity, V for final velocity, A for acceleration, T for time, and S for displacement. Now we will see the units of force. There are two types of units for force: absolute units and gravitational units. First we will discuss absolute unit. You know already the formula for force is mass into acceleration. The absolute CGS unit is Thyme and SI unit is Newton. When you write Newton as a unit, N should be a small letter. So these are the two units: absolute CGS unit and absolute SI unit of force. Now let us see what is the expansion of Thyme. The force is 1 Thyme when the mass is 1 gram and acceleration is 1 centimeter per second square. So 1 gram into 1 centimeter per second square, that is the expansion of Thyme. Similarly, when mass is 1 kilogram, acceleration is 1 meter per second square, then the force is 1 Newton. So Newton, its expansion is 1 kilogram meter per second square. Now let us study the definition of 1 Thyme and 1 Newton. How much force we call as 1 Thyme force or 1 Newton force. We will see the SI unit first. Consider a body of mass 1 kilogram kept on a table surface, and it is a moving body. Okay, suppose its initial velocity is 10 meter per second. A moving body, already this body is moving with a velocity of 10 meter per second and mass is 1 kilogram. And we apply certain force on this body in the same direction of motion, thereby its velocity changes to 11 meter per second, and the time taken to change this velocity is 1 second. That means due to certain force, velocity of this body changes from 10 meter per second to 11 meter per second, and time taken for this change is 1 second. Within 1 second, velocity change happened is 1 meter per second. Then acceleration of this body is v minus u by t. You will get the answer as 1 meter per second square. So means this body has an acceleration of 1 meter per second square and mass of the body is 1 kilogram. In such a case, the force exerted on the body is defined as 1 Newton. So the definition of 1 Newton is, it is the force which can bring an acceleration of 1 meter per second square on a body of mass 1 kilogram. Similarly, definition of Thyme is, it is the force which can bring an acceleration of 1 centimeter per second square on a body of mass 1 gram. Now let us see what is the relation between Newton and Thyme. 1 Newton, its expansion is 1 kilogram into 1 meter per second square. Force is equal to mass into acceleration. So 1 Newton means 1 kilogram into 1 meter per second square. Let us convert each term into CGS system. 1 kilogram stands for, or it is equal to 1000 gram. 1 meter per second square is equal to 100 centimeter per second. So it is equal to 10 to the power 5 gram centimeter per second square. Gram centimeter per second square, short form is Thyme. Okay. It is equal to 10 to the power 5 Thyme. So this is the relation between Newton and Thyme. 1 Newton is equal to 10 to the power 5 Thyme. Now about gravitational units. Gravitational units are also two types, CGS and SI. CGS unit is gram force, SI unit is meter per second square. Gram force is equal to 1 kilogram into 1 meter per second square. Force is equal to 10 to the power 5 gram. So this is the relation between Newton and Thyme. 1 Newton is equal to 10 to the power 5 Thyme. SI unit is kilogram force. These are the two absolute units of force. Now let us see the definition of each one. 1 gram force is the force with which a body of mass 1 gram is pulled by earth. You know, every object is pulled towards earth. Consider a body of mass 1 gram. With how much force earth pulls it towards it, that force is known as 1 gram force. Similarly, you can make the definition for 1 kilogram force. Consider a body of mass 1 kilogram. With how much force earth pulls it downward, that force we call as 1 kilogram force. Now let us see how to convert from kilogram force to Newton. Force is equal to mass into acceleration. In this case, acceleration, since body is moving towards earth or pulled towards earth, its acceleration will be g. Its value is 9.8 meter per second square. In the place of a, you are to write g. Acceleration, here is acceleration due to gravity. So mass is 1 kilogram, g 9.8 meter per second square. So answer is 9.8 kilogram meter per second square. Kilogram meter per second square is Newton. So it is equal to 9.8 Newton. So 1 kilogram force is same as 9.8 Newton. Similarly, 1 gram force, we can convert it into dynes. See how to convert. We will use the same formula. F is equal to m into g. Mass is 1 gram. In this case, g will be 980 centimeter per second square. Its constant value. G value in SI system 9.8 meter per second square. CBS system 980 centimeter per second square. So 980 gram centimeter per second square. Short form is dyne. So 1 gram force is same as 1 gram force is same as 980 times 1 kilogram force is same as 9.8 Newton. Okay, so this is what you have to study from the topic force and its units. Thank you.